for ionic polarizability. Yesterday we were supposed to do, but in this class let us discuss expression for ionic polarizability. Ionic polarizability is the second one in the types of polarizability. Ionic polarizability. In the previous class we discussed about electronic polarizability, the expression. Today we will learn about the expression for the ionic polarizability. So let us look what is our aim. Our aim is we need to know what is ionic polarizability. So let us start with the definition of ionic polarizability. Let me ask Virika. Can you define ionic polarizability? Just be silent. Don't silence from your bench. Nivas. That is the polarization. What is ionic polarization? You define. Ionic polarization happens due to the displacement of the ions in the ionic crystal. Agreed. What is ionic polarizability? It is denoted with alpha, right? Polarizability. So what is the definition? Because it is ionic polarizability, it is alpha. Tell me the formula for polarizability. Just Virika, nobody else. Polarizability is defined as, call that way. Where are you talking about? No sound is supposed to come. Not even come. Small alpha is equal, polarizability is equal, definition. Even after deriving so many things, you don't know the simple derivation. Machine depends. Dipole moment by, so the dipole moment small p by the electric field. So the dipole moment comes in the ionic polarization due to what? Who brings dipole moment in the ionic crystal? You apply electric field, due to that what happens? Ions will displace from their position, then you will get net dipole moment. Or nothing but you have charge, some charge you should be having, and you need to have a distance. So in order to find ionic polarizability, you need to know what is the charge, what is your electric field, and also the distance it moves. Right? Yeah. This setup. So we will start with that only. Let us take some charge, then you apply electric field. All you need to derive is what is your x. Because charge we are taking, E also we are applying, we know both of them. You need to know what is the distance it moves. So, like in the previous expression, we will start with case number 1 without the application of electric, without applying external electric, which means your E is equal. When E is equal to 0, by default you should be knowing your polarization is how much? 0. That means. So why it becomes 0? Somebody will explain. Ionic polarizability is possible in what kind of materials? We discussed yesterday. Is it realized in all the materials? Ionic polarizability, yes, you.
2 ions. Like dipoles must be.
Ion should be there.
Ion should be.
So you need to consider ionic crystal, guys. Ionic crystal unity. So let us start with consider an ionic crystal. Okay. Consider ionic crystal. Best example. NaC. Na has plus, Cl has minus, NaC. Take NaC. And you remember, both of them have different sizes. That also matters. Okay. So let us consider a ionic crystal, NaCl kind of thing. Na is plus, and I am calling Na plus as the mass, which is bigger, sodium or chloride. So I am considering its mass is smaller because it is smaller in size. And let me call chlorine. Chlorine has mass capital F. Why do you care about mass? Because you need to displace them. So if mass is more, it will move lesser distance compared to the lighter element. So that's why masses are actually important while you talk about ionic crystals. So let us consider ionic crystal, any ionic crystal, typically NaCl. Then Na has mass m, and let us take charge Q. One is plus Q, other one is minus Q. So charge Q and mass is small m and K. Let us take. Now you are looking at what happens when there is no electron. So the diagram is, this is your NaCl structure, and at the corners we have, if it is chlorine, next one is smaller mass, Na plus, next one is again chlorine, like this. Okay. So this is Cl minus, Na plus, Cl minus, plus, minus, plus. What you say, in the absence of external electric field, your polarization becomes zero. For the simple reason, who will tell that? Why the polarization becomes zero? Which direction you are talking? Can you show the direction? Somebody show me the direction. What's it? Just tell me why polarization is zero. Yeah, you can explain.
So because here the two dipoles are acting along different directions and they are of the same mass, so hence they cancel out each other.
Very good. So even though the dipoles are there, dipoles are pre-existed in the absence of the electric field, the direction being different, the net polarization becomes zero in the absence of the electric field. That is the first description you need to mention. You need to write the theoretical description along with the. But remember, let us consider one dipole for the simplicity. Don't take entire unit cell. This is called unit cell. Take any one dipole just for our simplicity. So I will pick up some dipole here. Now this dipole I am picking up. So if I write this dipole, it looks like this. This is plus and minus, right? This dipole I am writing. So from now we will consider only one dipole for the expression. It is just for our simplicity. Okay. So the dipole, which means it has negative charge and also positive charge, and it is separated with a distance. Some distance is already there. Okay. So let me call the distance d at the moment for our reference. And it has mass small m, it has mass capital. Clear up to here? So we have prepared everything. The ingredients are ready now. Now we will go into applied electric field and we will derive what happens. Up to here it is clear now? Yeah. Then let us go back to our case number 2. In the case number 2, what we are doing? Apply electric field. electric field is external, then we say apply external electric field, which means your E is not is equal to. I am not talking about entire unit cell, so the same dipole I am taking here. Right? Positive. That's this much. Now I applied my electric field in this direction. After application of the electric field, what happens? Look at that carefully. What happens? Suppose take this positive, or else you consider negative and tell me, try to tell me. Viresh, one of the Viresh tells us. What happens to the negative charge after the application of the electric? Stand up now, some Viresh is there, three of you are there. You tell me, man. What this chlorine will do? What this chlorine do after the application of the electric? It sees the electric field, right? What electric field is trying to do? Electric field is forcing. It is providing a direction, right? So what this guy will do? It moves means where will it move? It moves that side or this side, that side, this side. Four directions or many directions are there. Two positive, which means this side it will go. Why? Try to understand that again. Who will say from gents? Again, from the back bench. Second guy. What is your name? Vinay. Yeah, Vinay, tell me what happened. Opposite direction means? This side? Why will it move this side? You should have some reason, no? It's not just blindly. Why this negative ion moves that side? Why not this side?
The electric field passes.
Yeah, electric field goes this way. Then? Yeah. Meaning that no, electric field goes from positive to negative side. So the negative atoms, they get attracted towards positive side, right? So this moves this side. So it will move from this position to somewhere this position. Hello? It cannot go that side, man. Similarly, this positive guy goes from here to, it will move up to here. So this is the original position. These two are the original positions. But after the application of the electric field, it moved a distance. Now let me ask one more question. You both. No, the negative ion moved certain distance. Positive ion also moved certain distance. Usharan. Yeah. So is the distance same for both of them? Yes or no? If it is no, why? You need to think and tell me. Today you need to answer. I will not teach you. You said no, which means they don't move same distance. Yeah. Why? Just waiting. Media. Netravati. Your logic is correct. Half part of your statement is correct that they have different masses, so they move different distances. So by saying that, okay, I consider one moved a distance of x1, other moved a distance of x2. From where it moved? Hello, it moved from this distance. So the distance already there without application of the electric field itself, they have some distance. Okay, that is called mean distance. Okay, from there I move, not from the center. Okay, from D it moved to x2. From D it moved to x1. So while writing, how you need to write is the positive and negative ions moved from their mean position to a distance of x2 and x1 upon the application of the electric field. You need to frame that sentence. Now the second part of your statement is now which is larger in distance, x1 or x2?
X1 large.
Yeah, Suprita. Yes. X1 is larger compared to x2. What is your argument for that?
Mass
Because mass.
is large.
So mass is larger, therefore if you have a running race with me, who will win? You or me? Because mass is more, it will move fast. Then what logic you are applying, girls? Nobody is going for running now. Arey, why are you talking? Then kill you, man. Because mass is more here, it will move lesser distance compared to that. So why are you get confused? So the mass plays a role. Sit down. X1 and x2 are different. So therefore, the total distance, you want to know the total distance, x is nothing but the total distance. Total distance x is how much? x1 plus. Right. Now your aim is actually to find out what is x1 and what is x2. Then you substitute this x here, charge you know, electrical you know. Then you will get the expression for all part. That's it. So how do we find out x1 and x2? Same logic. While finding the electronic polarizability, you got x. What did you use? You used a condition. What condition you use? Vikram? What condition we use? X. At x. Equilibrium. Equilibrium condition. Hello, remember, you need to ask again, why x1, why can't it go, keep on going like that? Why x2? Now you applied the electric field, ion moved some distance and stopped it. You apply the electric field, ions are like this, one ion suppose, it moved up to certain distance, x1 and it stopped. Why it stopped only there? Why can't it keep on going? Why it stopped there? Equilibrium means what? What is happening?
Applied reaction at the electric force.
No, answer the Tanish. Who stopped that atom? Hello, at x1 you stop. Who said that? Why can't it freely go? Be louder and clear. You are saying correct. Yes.
Ions will attract.
So you need to understand here. Please sit down. All of you. x1 and x2 are the distances. At that distance something happened. What happened is competitive interactions are again there. One competitive interaction is electric force. Electric force says that okay, you need to separate out. But before the electric force, they were actually sticking together. right? Now you want to separate them, but a restoring force acts upon them. It is pulling back. So when this restoring force equals to the electric force, that is called equilibrium position. That is the position of x1 and x2. So apply the same principle, which means at equilibrium, what happens at equilibrium? Your electric force is equal to restoring force. We use this condition, then we can get what is x1 and x2. While writing the expression for electronic polarizability, it is Coulomb force versus electric force. Here it is your electric force versus the restoring force between the ions. It is now, imagine it is like a spring acting. We just pull the string, now it tries to come back to its original position due to the restoring force. Now what is the restoring force? Restoring force on ion, first ion, F1 is proportional to distance x1, and if you take out the proportionality constant, it will be denoted with, what is the constant, restoring force constant? K. Yes. K1 x1. You have studied this now. What is K1? What is K1? Force constant. K1 is equal to, has something, it depends on the mass, right? It depends on the mass and some other parameter also. Anybody remember? K is equal to, nobody remember? K is equal.
Online branch.
Mass into something square. What is the mass of x1? x1 distance is, its mass is capital M now. So capital M into omega square. Have you seen? K is equal to m omega square. Remember? Okay, spring constant. You say what is that? Okay, m omega square is there now. What is omega there? Omega is correct. What is omega? Movement. Angular velocity. Frequency. Angular frequency. See the atoms in any remember this. The ions are there in a given molecule, right? Ionic crystal you have taken. These guys are not stable. It's not like dead person. Because there is a temperature always. They vibrate with a natural frequency. Any material in this world if you take, they are actually vibrating inside. Okay. So they are called phonons. The vibrations are called phonons. So every solid, if you consider, they are vibrating with their natural frequency. That frequency is called angular frequency here. So that is omega for this specific NAC. Let us see. So you need to know your x1. But what is the force? This is the force. Is equivalent to what? F1 is equivalent to restoring force is equivalent to electric force. So, but this restoring force F1 is equal to electric force is nothing but E into Q is the charge and you apply electric field. So, let us equate them. Capital M omega square x1 is nothing but E into Q. Therefore, your x1 is nothing but EQ by capital M omega square. But similarly, historic force F2 is proportional to x2, and F2 is nothing but K2 into x2. Here your K2 is small m, but the frequency is same in the same material, so it is still omega. But your F2 is again EQ, therefore equating that small m omega square x2 is nothing but E into Q. From here, what is my x2? x2 is nothing but EQ by small m omega square. You need to write what is your omega. Omega is nothing but angular frequency. It is specific to the material. To the material changes, their frequency changes. For a given material, angular frequency is same. Remember. Right? Now, your total distance you want to know. That is our right. So therefore, my total distance x is nothing but x1 plus x2. So my x1 is EQ by capital M omega square. x2 is EQ by small m omega square, which will come common. EQ by omega square will come out as common. Then I have 1 by capital M plus 1 by small. This is x. Once I know the x, let us substitute there. What is your alpha I? Alpha I, if I write, is nothing but my charge q into my distance x. What is the distance? EQ by omega square into what is that? 1 by small m plus 1 by capital M. 1 by small m and 1 by capital M. Why? Electric field is there. Charge into distance by electric field. Right? That is the formula for the polarizability. So E will cancel out each other. You have Q into Q, nothing but Q square. So Q square by omega square, Q square by omega square into 1 by small m plus 1 by capital M. That is the expression for alpha. Look, alpha is depends only on the masses, not on the temperature. That is. So electronic polarizability depends on what? Final expression what did you get? R cube. Cube of the atomic radius. No temperature dependence. Here also ionic polarizability doesn't depend on its temperature. It depends on the masses. Right?